we have decided to host Dr. Hema Singh, and she has done a very, very significant contribution, especially in the RCS and phased arrays. So that has a direct relevance with antennas and microwave. And to initiate this idea, I would like to congratulate Kirti Priya and Dr. Sweta Amit. Uh, Both of them have taken this initiative and came up with the idea for conducting not one day program or a week program. They have come up with the idea to conduct this entire month. Every week we will be having on every Tuesday 7 to 8 p.m. this series, and we have reached out to very, very prominent as well as young achievers, both who have done a very significant contribution in the field of microwaves. And I can see a good participation, not only from women technologists, but from the men as well. So that shows that at least in our chapter, we both are men and women. We are having hand in hand and supporting each other in helping and promoting each other's activities as well as work. So with this small intro, I would also like to take this opportunity to invite each one of you to submit paper in our own IEEE MapCon, which is going to be hosted by, again, IEEE APMTT Bangalore chapter, and the dates are from December 12th to 15th, and all the fields of antennas, microwave, and propagation are being covered in this particular conference, because we have merged INCAP as well as IMARC both. And I'm very happy to share that the who's who of the country, in fact, where I can say most of the 60% antenna and microwave work is done in ISRO as well as DRDO. Both the chairmen, both the secretaries of these departments, they have agreed to be the chief patron. It is a very good. We are going to have, I can say, we are targeting for 1,000 plus delegates and similar number of papers in this particular conference. So you all are invited to participate and submit your original research work. And we have done and created a huge award program for the papers, where the best paper is going to be 50,000 rupees, that too for academia separate and industry separate. So I'm taking this opportunity to promote MapCon as well, even though this program is very focused on women in microwaves. With this, again, I would like to invite Dr. Hema Singh, and again, I am congratulating Kirti Priya and Sweta Amit for taking this initiative, wonderful initiative, I say, where we have started this series. Over to you, Kirti Priya.
Thank you so much, Puneet sir. It's a pleasure to have you with us today. So Puneet sir will be joining Hema ma'am on fireside chat shortly after her talk. So everyone can stay back after the talk for that also. So Hema ma'am, you can share your screen. While you share your screen, I request now Dr. Sweta Amit to introduce the speaker to the audience. Over to you, Sweta ma'am.
Thank you, Kirti Priya. Well, it's a great opportunity to introduce Hema ma'am to everyone. Dr. Hema Singh ma'am is working as Senior Principal Scientist in Center for Electromagnetics, National Aerospace Laboratories, Bangalore, India. Dr. Singh has academic experience in highly prestigious BITS Pilani. She has been involved in training manpower, that's postgraduate students in the field of electromagnetics. Presently, she is also holding position of Associate Professor of the ACSIR Academy in the Faculty of Engineering Sciences. She has received PhD degree in Electronics Engineering from IIT BHU, Varanasi, India in February 2000. Her focus area of research is indigenous development of stealth technology, one of the critical challenge in the country's self-reliance and in strategic sectors. So this involves active RCS reduction, radar absorbing structures, RCS estimation and control, low RCS phased arrays, plasma-based RCS reduction, antenna radome interactions, pattern synthesis, and adaptive array processing, which is one of the critical challenges in strategic sectors. Other contributions of Dr. Singh ma'am include EM analysis of propagation in an indoor environment for Boeing USA, HIS-based phased array design, RCS estimation of electrically large structures, and conformal arrays. She has authored 15 books, 2 book chapters, 1 patent filed, and 7 software copyrights, and 400 research papers and technical documents in these research areas. She has a total of 22 years of works experience in academic and R&D organizations. She has received IEEE Women Technologist of Year 2020 by IEEE Bangalore chapter. She also got IETE Srimati Ranjana Pal Memorial Award 2018 in the novel area of active RCS reduction by indigenously developing an effective adaptive algorithm. She was awarded Best Women Scientist in CSIR NAL in 2008. She is Senior IEEE member. She has been Asia representative in IEEE Industry Initiative Committee. She is also member of India Society for Advancement of Material and Process Engineering and Aeronautical Society of India. Ma'am, we welcome you today for your inspirational technological talk. Welcome, ma'am. Over to you.
Thank you. Thank you for, thank you, Dr. Shweta. So now I will try to share my slides. I think it is not. I don't know.
Ma'am, you're having the share button below.
Yeah, I clicked that.
Okay.
But wait. So if I am putting can you see my slides? No, na?
Not yet, ma'am.
I don't know what is the problem. No, this thing.
Can you just try again? Probably just share that window where the PPT is being open.
No, it is showing that switch to, mother, this is not supporting. Actually, I am running this through web app. Now it is asking to switch to desktop app. And
Okay.
when I'm going there, then it is not, again, some problem is coming.
Can you email it to me, ma'am? I can.
That's better. I will
Yeah.
forward my.
Mail to us, we will upload from here.
Yeah. That I will do. Yeah. That email ID, can you tell? Hello? Can you tell your email ID?
Mine is Mishra, MISHRA_Puneet at IEEE.org.
Mishra underscore.
Puneet,
Hmm.
PUNEET
Puneet.
at IEEE.org. And you can share to Kirti Priya and Shweta also. They have typed their mail IDs in the box. Hope you are able to see the chat box.
I have sent. Puneet, can you see?
Okay, I will check. Yeah.
That slide is little, that file is big, so I have sent you.
Okay. Not yet received. It may take some time. Yeah, I got it.
So Puneet sir, can you share that screen then? Because I
Yeah,
will
it is getting downloaded. I will share. Yeah, 1 second.
Yeah.
It's a big file, so it is taking some time. Next time, Kirti, I think it's better to collect presentation beforehand
Yeah,
so that we are
that's
ready.
better.
Yeah.
Yeah. Sorry for the technical glitch to all participants. We'll shortly start the talk.
So let me know if my screen is visible to all of you.
Yes, sir. Your screen is starting to be shared. Yeah, we can see the screen.
Okay. So let us go to the full screen mode. Yeah. So Dr. Hema, you can start now.
Hema ma'am, you're on mute, I think.
Good evening, everybody. Uh, so, wish you a very happy International Women's Day. And today I am going to talk about
Dr. Hema, I think we lost you.
Hema ma'am, your connection is not good. We lost you in the beginning sentence itself. Can you just speak now? No, you are not audible. No, ma'am, you are not yet audible. Initially it was fine. Now there is some issue. We can see you actually, but we cannot hear you. Ma'am, you're already the co-host. 1 second. You have logged in from 2 different systems. Okay, can you try now?
So now, shall I start?
Yeah. Fine.
So good evening, everybody. I would like to wish you very happy International Women's Day. Today I am going to talk on radar cross-section of phased arrays, estimation and control. This is first lecture in the series, special lecture series for women in microwave. Organized by IEEE APMTT Bangalore Joint Chapter. So I want to express my thanks to IEEE Bangalore Chapter for giving me this opportunity to be part of this celebration and share my work. I am actually working currently as a senior principal scientist in Center for Electromagnetics of CSIR NAL Bangalore. Next slide, Puneet sir. Puneet sir, next slide. So I come from Center for Electromagnetics, which is a part of CSIR NAL. This division was founded by late Dr. Rakesh Mohan Jha, who was my mentor, and this division has been working in different areas, which include radar cross-section and infrared signature studies, radar absorbing materials and structures, phased antenna arrays, radomes, airborne antennas, metamaterials, development of computational technique, EM material characterization, and atmospheric electromagnetics. We have very small group of scientists and technical staff. Next slide. So my topic, this RCS of phased array, it comes under stealth technology, also known as low observable technology. Its main objective is to enhance the survivability of defense vehicles by reducing its RCS. The RCS reduction covers a range of techniques.
Dr. Hema, I think we lost you again.
Yeah.
I think she's having a poor connection at home, so maybe the reason.
Yeah. Hema, can you speak now? I think you're on mute. Can you unmute?
So
Yeah, now it's fine.
sorry for this. The RCS reduction covers range of techniques used in aircraft, ships, submarines, missiles, and satellites to make them less detectable. Actually, ideally invisible to enemy radars. These techniques are shaping using radar absorbing materials and structures, implementation of passive and active techniques such as probe suppression, active RCS reduction, and plasma based RCS reduction. Next slide. So when we talk about any aerospace vehicle, the overall radar cross-section of any aerospace vehicle is due to its structure and various antennas and antenna arrays mounted over it. Structure of vehicle, that RCS can be controlled by shaping and ram coating, but when it comes to antennas, that we have additional challenge, because antenna so can you hear me?
Yes, now we can hear you.
Probably, I think you can switch off your video so that you get a sufficient bandwidth. Now.
Okay, I will stop video and then tell. So I was talking about the antenna RCS. Here, that as far as scattering from the antenna is concerned, there is an additional challenge. For stealth or low RCS platform, it is not only required that antenna should have low RCS, it is also expected to have a high performance in terms of gain, side lobe level, size and weight. So it is essential that any active or passive techniques which is used to reduce array RCS should not degrade its performance. The structural RCS of antenna can be reduced by an efficient design by using high impedance surface, reduce ground plane, superstrates, parasitic elements. But when antenna mode RCS comes into picture, it can be controlled only by placing nulls in the probing direction, and this concept is called active RCS reduction. Next slide. No, now we come to RCS of phased array. We all know what are phased arrays. They are array of antenna elements like aperture, slot, horn, microstrip patch, spiral antenna, dipole antenna, used to achieve high directivity. It also affects RCS of a platform on which it is mounted. The estimation and thereby reduction of phased antenna array, we need to consider scattering in both in-band and out-of-band thread frequencies. Next slide. Next slide, Puneet sir.
Yeah, it's done.
Okay, sorry. The scattering analysis of phased antenna arrays include the two scattering modes, the antenna radiation mode and the structural mode. The antenna mode occurs when the induced current in the antenna feed point is reflected and then re-radiated. This antenna mode is determined only by the radiation properties of the antenna and is proportional to gain of the antenna in a given direction. On the other hand, the structural mode is generated from the current induced on the antenna surface. And these two modes are not easily identifiable or separable, and especially when antenna array is mounted on the platform. So, for a well-designed antenna array, it is required that both these antenna mode and structural mode scattering terms should be very small within the operating band of the antenna. The radiation and scattering characteristic of antenna array are dependent on the relative frequency range of the antenna array with respect to that of the radar. In case the frequency of radar signal falls within the operating band of the antenna array, then the impinging signal will match with that of antenna elements. And due to this impedance matching, the signal will penetrate into the feed structure. This signal will result in multiple reflection within the antenna system and hence contribute significantly to the RCS of antenna array. Alternately, if frequency of impinging signal is outside the operating band of the antenna, then there will be no match between the incident radar signal and the antenna elements. And in this case, the reflection inside the feed become insignificant. In order to accurately estimate the RCS of phased array, it is required that the scattered field at each level within the antenna system should be taken into account. Even we have to include edge effects and mutual coupling effect also. The situation becomes more complex when the surface or the platform becomes non-planar. Here, as you can see from the figure here given, that phased array system has different levels: radiating element level, phase shifter level, coupler level, terminating load. So every scattering at each and every level has to be taken into account. Next slide. When an antenna is mounted on the platform, it has twofold impact on the RCS of the platform. First, the antenna significantly disturbs the continuity of the surface. For example, if we mount an antenna array on the surface of the aircraft, holes are required to be drilled. And these holes introduce more number of edges and hence scattering. Also, a well-designed antenna has a potential to absorb almost all the incident energy in its operating band. So if there is a plate with an antenna installed, then its scattering characteristic will be similar to that of plate with hole in it. And these two factors collectively give rise to wide angle scattering. Secondly, threat radar signal can penetrate into the feed of the antenna system and get reflected at internal mismatches and junctions. Even though these mismatches are very small in the operating band, but they may result in multiple scattering source for a large antenna array. And these individual contribution may add constructively under some conditions. This scattering is all dependent on type of the feed network and the components incorporated within the antenna system. And this complicates the RCS prediction of phased arrays. So let's see this equation, which is the basic equation of antenna scattering, and it gives the total scattered field for a linearly polarized antenna. One can see that here the scattered field is proportional to the gamma. The gamma is reflection coefficient, and when the load impedance becomes equal to complex conjugate of the radiation impedance, antenna is said to be conjugate matched. Under such condition, reflection coefficient becomes 0. Thus, there will be no reflection at the junction of the antenna and the transmission line. And it can be observed from the equation that it has two terms. The first term is the structural mode and the second term is the radiation mode. And I have already told structural mode scattering is generated by the current induced on the antenna and the platform. Next slide. And in contrast, antenna mode scattering depends on radiation properties of the antenna and is proportional to antenna gain. We know that phased array is required to have high performance in terms of the gain, but at the same time, it should have low RCS. So if we see the figure given in this slide, that when an incident wave enters into the feed network for an in-band operational antenna, tracing of the signal through the feed requires the consideration of each internal junction and device at which reflection occurs. The portion of the signal that is not reflected by the antenna aperture is transmitted into the feed, where it proceeds towards the input port of the phase shifter, because after radiating element there are phase shifters. If this phase shifter is not matched with the transmission line, a small reflected signal determined by its reflection coefficient gets propagated back towards the radiating aperture. And since radiating element is a reciprocal device, again one second order reflection may occur. Now further, the fraction of signal that has entered into the phase shifter will undergo phase shift determined by its transmission coefficient, and this phase shifted thread signal will travel through the transmission line and enters the coupler, because after phase shifter there is a coupler. The scattering at the coupler is dependent on the type of the feed, because now that architecture or configuration depends on the feed, whether it is series feed, parallel feed, corporate feed. So we need to know the type of the feed as well. And here you can see that RCS is expressed in terms of reflection coefficient and transmission coefficient. Next slide. So here we see that this is series feed network for a linear antenna array. So in a series feed, the power to each antenna element is tapped off from the main line sequentially using couplers. Following the coupler, there are phase shifters which are arranged either along the main line or the branch lines. These phase shifters facilitate beam scanning as they vary the phase of the signal being fed to the antenna element. The main feed line of series feed network is terminated by a match load. This causes some power to reflect back from the load. And here one can see from the expressions given that RCS due to each level, that is radiating element, phase shifters, and then couplers, everything is expressed in terms of gamma and tau. That means reflection coefficient and transmission coefficient of that particular component. Next slide. So here we can see from this figure that suppose the signal is received by nth antenna element, it acts as an excitation for elements towards the load constituting forward traveling wave, and also elements towards the input which is called backward traveling wave. So for each antenna element there will be one self-reflected wave and also one input load reflected wave. So these all individual contributions have to be taken into account. So next slide. So here, as I mentioned, that each individual component contribution from the level is then coherently summed to arrive at total array RCS. So detail of these derivations can be referred to this book, which is published as Springer Brief. And here on the right hand side, you can see a typical RCS pattern of 64 element series fed linear array. You can see that there is one main lobe at 0 degree which is called specular lobe, and there is another lobe which is round at minus 20 degree which is called lobe due to reflections from the input load. Next slide. Next slide. Puneet sir. Next slide.
Yeah, already I have gone to the next.
Oh,
I think some
okay.
delay is there.
Yeah. Okay. So now this was series feed network. Then next is a parallel feed network. Here you can see that now that arrangement of phase shifter and coupler are different. So we have to trace the path of the signal as it travels from the radiating elements towards the terminating load, and then calculate each contribution, that RCS due to radiating element, RCS due to phase shifter, coupler, and then after getting each contribution, then we have to coherently sum to arrive at total array RCS. Next slide. I think there is a delay. So one can see how complicated it is, that we will arrive at big expressions depending upon the path of the signal. So in case of parallel feed network, even there can be multiple levels of couplers. We have to take into account each level. And here couplers are modeled as 4-port device. And this last equation represents that total RCS of parallel fed phased array. Next slide.
I have moved to the next slide. You can see.
Now, yes. So this slide shows broadside RCS as well as scanned RCS. So here I want to highlight here that one can see that in case of scanned RCS, there are additional lobes. And even that specular lobe has also changed. It is because of extra level of scattering within the couplers. Next slide. Yeah. So this slide shows that when suppose number of elements are increasing, for example, n equal to 16 to n equal to 128, then one can see that location of major lobes remain unaltered while their level increases, which is expected that more the number of antenna elements, larger will be the antenna array, and it should have higher RCS. And also lobes in the pattern will become narrower, sharper, and hence more pronounced. And also there will be increase in number of side lobes. Next slide. So here this slide demonstrates the effect of inter-element spacing on the RCS pattern of antenna array. Suppose if we have spacing of half lambda and another array is having inter-element spacing of lambda, then one can see that although specular lobe remains same, but additional lobes next to specular lobe will arise due to mismatches between the second level, and additional lobes, it will have more number of additional lobes in the RCS pattern. Next slide. So in order to have even more clearer picture, I am showing you here contour plot. First one is of square array, 16 cross 16 antenna element. You can see the symmetry in the contour plot of RCS. And this symmetry is lost when we shift to rectangular array 16 cross 10. And here, since you can see that x-axis 16 elements are there, so you can see more red color along the x-axis as compared to the y-axis. Next slide. So here one can see that when beam is scanned from 0 degree to 45 degree, additional lobes are visible, and it is actually very prominently can be observed in contour plot. And the main lobe, which is at the center, it remains same, and even color doesn't change, means its level is also same, but additional lobes will arise due to beam scanning. Next slide. Now we come to cylindrical array. Here cylindrical array is a non-planar or conformal antenna array. We know that we prefer conformal antenna array over the planar one in lieu of wide angle coverage, space constraints, structural issues, and low RCS. In planar array, antenna elements are aligned along a specific axis, whereas in case of conformal array, the orientation of antenna element changes with the curvature of the platform. The non-planar geometry requires the transformation of azimuth and elevation angle from local coordinate to the global coordinates while calculating array factor and the scattered field. This transformation can be done using Euler's rotation, and the conformal array design has various challenges towards the optimum in order to achieve optimum radiation characteristic along with low RCS. Here one can see that here that scattering till first level and second level coupler is shown, and in case of second level coupler, small additional lobes can be seen in the rectangular plot, which is very clearly visible in case of contour plot, that the additional lobe, more red color you can see in at the center. And also here also we can see that as compared to broadside RCS pattern, in case of scanned RCS, we have additional lobes. Next slide. I want to specifically actually mention that RCS pattern and radiation pattern, they are related to each other. RCS pattern of any antenna array is equivalent to radiation pattern of the same array at same frequency but with double inter-element spacing. So its shape changes. It is same as RCS pattern will be same as radiation pattern but with radiation pattern of larger, double the size. So, next slide. So this also, again, I wanted to tell that even through optimum design of phased antenna array can also contribute towards control of RCS. Here you can see that left side broadside array RCS of unequal length dipole is shown, whereas if instead of having unequal length, if we have random length dipole, same antenna array can give low RCS. So even optimizing the design parameters of phased array properly, we can control RCS of phased array. But this will be structural RCS. Next slide. So here, suppose dipole array is arranged in different geometrical pattern, either side by side or collinear or parallel in echelon, then even we can control RCS. We can see that parallel in echelon has lowest RCS, while dipole array in collinear configuration will have higher RCS. Now I would come to the point why radiation mode RCS cannot be ignored. As I mentioned that RCS of aircraft is equal to RCS of platform plus RCS of antenna. And antenna RCS itself has two components, structural RCS and radiation mode RCS. This radiation mode RCS is the RCS when antenna is switched on, when antenna is radiating. And this has significant value. So this radiation mode RCS dominates over RCS of the platform. Puneet sir, please click so that there is a graph which compares that. You can see that for any stealth platform, generic stealth platform, suppose that RCS is 0.5 dBsm, then array RCS will be, structural RCS will be 0.01 dBsm by optimized design. But at the same time, if you switch on that antenna, this RCS goes to 20 dBsm, which is much more than the overall RCS. Please click, sir. So if radiation mode RCS of phased array mounted is not controlled, then stealth platform has no meaning. Next slide. So here it is required that structural RCS of platform and antenna should be integrated with active RCS in order to achieve overall RCS reduction in probing direction in real-time scenario. And this concept has been theoretically established by CSIR NAL. However, if you ask that whether in country this technology exists, no, it doesn't exist, and it is still to be implemented. Please click, sir. Next. So details of all this concept and derivation of RCS you can refer to this book. Next. So what I was talking, that in active RCS reduction, we need to actively place null in the RCS pattern. That can be done only once we have efficient adaptive algorithm, which can control radiation pattern as well as RCS pattern in real-time scenario. So we have developed in CSIR NAL one efficient modified improved LMS algorithm. Next slide, sir. Which can work for any arbitrary signal environment and for both flat and conformal antenna array, either whether it is linear or planar, whether it is flat or it's a cylindrical or it's a curved. So you can see that it is a very fast algorithm which can give converged solution for any arbitrary signal environment. So as as an example, you can see that suppose there are two probing radar, two enemy radars which are trying to see our antenna or our aircraft. So they are shown as red arrows, and this antenna must be communicating in particular direction for some application. Let it be by shown by green arrow. Then you can see that without disturbing its original purpose, means place that maintaining the main lobe towards the green arrow, you can see deep nulls have been placed towards each of the enemy radar, means at 20 degree, at 120 degree. So this is case of linear array. Similarly, I will show you some few results for other scenario. Next slide. So you can see that this is a dipole array. Here also there are two sources, two probing source and one desired source, one friendly source. So here communication between the with the friendly source is maintained, and at the same time the probing directions are suppressed, probing radars are suppressed by placing null. Next slide. There it can happen that even there can be simultaneously multiple desired direction, then even then also those all the lobes, all the main lobes towards the desired directions can be maintained at the while placing null towards the probing direction. Next. So this you can see even three desired sources and multiple probing sources can be handled by this algorithm, both for flat as well as conformal dipole array, even placed over dielectric cylinder. So this shows efficacy of the developed adaptive algorithm. Next. So here you can see that same antenna array, if it is flat or it's a conformal, that purpose is solved, means each of the probing source is suppressed. Next. So this was radiation pattern. Placing null in radiation pattern is relatively easy. Main thing is how to control RCS. So if this type of algorithm is implemented in the signal processing module of antenna system, then even one can place null towards the RCS pattern, in RCS pattern towards the probing direction. So this I will show you. Here the plus point in case of RCS pattern is that we know that there will be one main lobe, specular lobe, and maximum 2 or 3 lobes are there which are actually which are noticeable. Other side lobes are actually at very low level. So we have to be worried only that if probing radar is towards these higher lobes. So next slide. So here one can see there are two probing sources at -36 and 25 degree. In case of adaptive RCS pattern shown by blue curve, one can see that nulls have been placed. So those probing radar cannot see any RCS toward from this antenna. Next. So this algorithm actually works for both series fed dipole array and parallel fed dipole array. Next, so even there, if suppose probing radars are very close to each other, this algorithm is capable of handling or suppressing these enemy sources. Next. So this now comes this parallel feed network. Even in this case also, that probing radar can be suppressed. Next slide. So here two sources are suppressed efficiently. Next. So closely spaced also radar sources can be suppressed. Next. So this was active RCS reduction. Now I would like to share even some work which actually we have done towards reduction of both structural RCS and radiation mode RCS for low profile antenna array. So details can be referred to our this book. Next slide. So here suppose there is a microstrip patch array with conventional PC ground, then we are capable of calculating its structural RCS as well as the radiation mode RCS. And even from this graph on the lower right hand side, you can see that radiation mode RCS is much higher than the structural mode RCS. So this is the serious issue which should be handled by efficient antenna designers. Next. So this was conventional microstrip patch antenna. So how to reduce structural RCS or radiation mode RCS of such antenna? For that, what we have done, that we have modified the ground plane. Next slide, sir. So in that ground plane, we have introduced FSS elements, and we have even modified the ground plane. We have reduced ground plane, and we got very good result in terms of both structural RCS as well as radiation mode RCS, that over wide frequency range we got RCS reduction. But at the same time, you can see that its gain is not disturbed. Next slide. So that was the flat one. Even this design works for conformal configuration also. Here also we got significant RCS reduction over wide frequency range without disturbing its radiation characteristics. Next slide. So another way to reduce RCS of antenna array is to use superstrates. Sometimes it is the requirement of customer is that they don't want to disturb their antenna. They don't want any changes in the antennas. Then how to reduce RCS of such antenna? In that case, superstrate is the technique which can be used to reduce RCS, and at the same time gain and VSWR and other radiation parameters can be maintained. Here we have used periodic structure based design and also parasitic antenna elements in the antenna structure so as to get very good results. This type of design has been even fabricated and measured. Next slide. So here you can see that we got wideband RCS reduction without disturbing its gain and return loss. Next. So we have also done some RCS analysis of Vivaldi antenna array, because such antennas are used in fire control radar system and also of fighter aircrafts. So here is in this slide, 8 element Vivaldi antenna array with phase shifters is shown. Next slide. So this type of antenna, both structural RCS and radiation mode RCS was determined. So, so this is co-polarized and cross-polarized gain, and also variation of gain with frequency. And these Vivaldi antenna arrays are basically end fire antennas. So end fire antennas have generally low frontal RCS. That's why they are generally preferred in case of fighter aircrafts. So even that analysis can be done using same method what I have described in this lecture. Next slide. So here one can see that this is the structural RCS versus frequency, and also the radiation mode RCS. So only in calculating radiation mode RCS, we have to trace the signal. So all this work actually I have published in form of different books which are available in open domain. People who are interested in doing work in this area can refer these books. Detailed analytical expression with derivation is provided in these books. So even people who are in the beginner level, they can also learn how to calculate RCS of phased array. These are my books. Next. I have also, apart from books, I have also published book chapter also. So next slides.
I think Kirtipriya, now you can take over for the questions and answers.
Thank you.
Thank you, sir. Thank you, ma'am. It was a very extensive talk. So probably we have, a couple of comments in the chat box here. This is from Mahadevan sir, saying that series feed will have problem of low reliability. A single point failure can result in total failure. Do you have any comments for this comment?
Yes, the series feed are not the best choice. Actually, what I want to present here, that any type of feed network can be handled for RCS estimation using this method. So series feed is actually not preferred one. Nowadays, corporate feed and even more complicated feeds are being used in actual radar systems. So starting from series feed, even parallel feed, corporate feed, and even some arbitrary feed can also be handled, provided if somebody has all information related to components and the elements used in the antenna system, then RCS can be determined.
So another comment from him is, how about probe suppression during scanning? Is the algorithm adaptive?
Yes, yes. Even for beam scanned, but if when beam is scanning, that time also probe suppression can be handled with using this algorithm. We have tested.
Okay. There's one more question, but it's not very clear. Anupam, if you can again type the question. Yeah.
RCS with all red.
Yeah, RCS versus, so the question is RCS versus RCS with all radar on is calculated, which I'm not really clear on the question. Anupam, if you can just extensively write the question out in the chat box, it will be nice. There's one more, I think, comment from Mahadevan sir again, that the inter-element spacing of 1 lambda will result in the grating lobes too. So how will the grating lobes there? Yeah.
It was just an example to show that actually if we change even inter-element spacing, that is going to change RCS pattern. That point is this. Yes, we know nobody uses lambda spacing, inter-element spacing, because it will, yes, it is true that it will give rise to grating lobes and other problems also.
How do we calculate RCS with all the antennas? Radiating at the same time. I think that is the question from.
Okay, multiple antenna radiating. How to calculate RCS?
Yeah.
For that, each antenna's RCS has to be computed, and you are talking means overall RCS of the platform with all the antennas switched at the same time, switch on at the same time. Yes, we need to consider all of them, and and coherent superposition of each contribution from each of the sensor, each of the antenna plus platform has to be taken into account.
Okay. Another question is, how sensitive is the algorithm with respect to phase and amplitude variation, specifically?
Yes, it is very much sensitive. It is very much sensitive. It has taken into account that.
Specifically with respect to placing nulls is the continuation in the question.
Otherwise it will not be able to place null if both amplitude and phase is not taken into care. The null is game of phase only.
Thank you, ma'am. I think these are the questions in the chat box so far. I think we are continuing with the fireside chat also. Maybe if you have more questions, participants can put it in the chat box. Maybe we'll try to take it after the chat session. So Puneet sir, you can please take over the chat session.
Yeah, thank you, Kirtipriya. And before starting the fireside chat, I would like to again congratulate Dr. Hema Singh for providing a very, very nice and exhaustive presentation on the RCS and RCS reduction techniques. And I was impressed with that particular theoretical scheme, which you have shown that in the main lobe side, you can create a null and still you can hide the things from
Yeah.
probing things.
Yes.
So I'm surprised that nobody is to implement that theoretical thing in actual application. So
Sir,
I think
we are also, sir, we are also trying to implement this hardware wise experimentally. Only that that budget, that sanction issues. So we have been trying.
yeah. So I think that will change the whole game of this RCS reduction. The moment if it is successful, I think we will having a whole applications in the RCS field by you. And so just go to because I have to join a parallel on for Indian Council. So let us do it, madam. So first, I would like to know, can you please tell me about your childhood and studies? What prompted you to choose a tough field of electromagnetics, RF, and microwave, and that too again in RCS? I think Dr. Hema Singh, you are able to hear us. You can unmute yourself.
Yeah, I think, ma'am, actually,
Now I
you
can.
turn off
Sorry.
your video so that we get the
Yeah,
bandwidth.
I have stopped my video. I understood it.
Yeah,
Video
yeah,
problem.
yeah.
Yeah, you were asking about my childhood.
Yeah, childhood and studies, and what prompted you to choose the field of electromagnetics, RF, and antennas?
Yeah. So the thing is that I am from that family of army background. My father was in army, um, and so I studied in government school Kendriya Vidyalaya. So I was good in studies from beginning, but I never had planned to do PhD. But somehow various circumstances or situation or destiny, what you can say, that I went BHU for doing PhD there. I joined PhD in electronics engineering department under under Professor Venkatesh Varlu and Professor KP Singh. They were working in this microwave and electromagnetics. So my PhD topic was decided that time. First, I was also like any fresh student. I was not aware of details of electromagnetics, but during my PhD, that is almost 5 years, I rigorously studied electromagnetics, gone through various books. Slowly, I started developing interest in this area, and my topic was radar cross section only. So automatic, and my guide also supported me. He pushed me to attend various courses, various seminars, workshops. Actually, I in Hyderabad, in Bangalore. So he used to send me every year from Varanasi. So slowly, I got to know about big people working in this area. So this interest actually kept growing, and uh, for after my PhD, for some time I had academic experience. I was working in BITS Pilani, but again there Dr. Rakesh Mohanja, who was from NAL, he was actually alumni of BITS Pilani. So he went there for giving lecture. There he met me, and then he told that since I have done PhD in RCS, I should not be in BITS Pilani. Actually, correct place is NAL. So that way I came to NAL, and under his mentorship, I did so many projects, and I have done this type of work. So it is
Yeah,
because
I
of
can see
encouragement. It
most
is
of your books are along with Dr. Jha.
Yes,
So
he only pushed me. He pushed me. That
yes,
actually he got to know that I have interest in writing and expressing my work in proper way. So he told I know your strength is in writing. So please transfer your knowledge in form of books. So I did that.
So I was fortunate to meet him personally. Actually, when I joined ISRO,
Yes.
and we had very nice session and he was very much instrumental in your variable thickness radome
Yes,
development, which is
yes,
flying on Jaguars.
yes,
So his contributions are really, I can say, they are helping the nation. So
yes,
quickly
yes,
going to the next question, Dr. Hema,
yes.
I would like to know, being a woman,
Mm.
have you seen any discrimination at studies as well as in your professional career?
See, I actually see the except very few cases, I have not actually experienced this much. But it's not that I should not say that zero discrimination. I always got there is discrimination, but it depends on individual thinking. That few people only actually very few people in present age they think that women or females are not less they cannot do as men can do actually. uh, mm, we are lucky now that that educated men they don't think like this, and even if they think, I would like to tell that even they think, if we are working hard, if we keep putting our 100% effort, I don't think so anybody can stop us. So,
Yeah, I think you have told a very valid point that
mm,
nothing can substitute the hard work, and if you are
yes.
hardworking, nobody can stop you.
Uh,
And yes, because of education and lot of things
mm,
happening around,
mhm.
now women are treated equal to men,
Yeah.
and there is no bias involved, or if it is there, at least we are not seeing in open. So thank you for your input.
Yes.
Now I will to go to the last question.
Mm.
What message you would like to give to the other women in microwaves?
Yes, what actually, based on my experience, especially young ones, and even that middle-aged one, all ladies, I want to request that never think that you are less than anybody, and keep working hard, be positive, even you are getting favorable environment or you are not getting favorable environment. Keep working hard, keep expressing yourself. If suppose you feel that here you should open your mouth, please open your mouth, please express. And also you need to come forward. And especially what I actually have felt in my life, professional life especially, that when it comes to leadership, when it comes to give some higher post, there generally we don't see many ladies. If you see around in your organization, you just count how many HODs or how many directors ladies are. There are very few numbers. So we cannot blame male. Actually, we only don't put effort. We don't we always we keep ourselves at back foot. Why? We should not do it. We should come forward. Be confident. Actually, women are capable of doing multitasking. They can take care of family as well as that outside world. So we should not be shy. So this is
Yeah,
my
so thank you, Dr. Hema Singh, for your wonderful perspective. And being International Women's Day, we thought that let us extend this session with this fireside chat,
yeah, it
where
was.
after your technical session, which was really intriguing, so we should have some kind of a discussion so that the attendees who are joining this can know more about you and what kind of encouragement, support, or barrier you have faced in your studies as well as in professional growth. And at the end, we had a wonderful message from your side. So I request each one of us to join, to switch on our camera so that we can have a group photo before concluding this session. So I request each one of you to please switch on your cameras.
I'm afraid if I start video, it will go.
No problem. This time, even we are not going to think, so you can switch on your camera.
Okay.
Yeah. So I can see Mahadevan sir. He is always there with us for encouragement. So his attendance is 100%. I can say So good. So we are having almost 25 participants, and now, in fact, the craze of online things are becoming less. So people want physical meetings, but still we are having good attendance. So yeah, I request each one of you to switch on your camera so that we can have a group photo. And request our omnipresent Chengappa ji to take a snap. No, he is really omnipresent. You are having 5 parallel meetings, you may find him in at least 2 or 3. So we should commend his passionate volunteering as well as time management, I should say. So which is very rare, I can say, skill. At least I'm not having that kind of a skill what Chingappa is having. So still I can see half of them have not switched on. I think they may be in a situation that they cannot switch on. They may be driving or having some food. So let us have this photo, and I request Kirti Priya to take it forward now.
Thank you so much, Puneet sir. Thank you so much, Hema ma'am, and all the other
Thank you.
participants. It was such an informative talk, and the last message was really wonderful because I was anyway going to ask regarding this leadership question on to you, like how do you perceive this? Because they say that women are not there in the leadership positions in most of the corporates and all. You have statistics everywhere saying that. So I was going to ask you the leadership question, and you answered it beforehand. So it was a great and informative session, ma'am. Thank you so much. And for
Thank
all
you.
the participants, we are having the next talk on next Tuesday, same time, 7 to 8 p.m. So request all of you to join for the talks again. Thank you all.
Thank you. Thank you.
Close the
Thank you.
session here.
Bye-bye.
Bye bye. Good night.